Cool. Hey everyone, I'm Ivan from MultiVM. So what we have built is a DeFi, or not DeFi, but a primitive for having multiple virtual machines in one system. This looks a little bit like that. So imagine you have RISC-V as the underlying processor. For now, we are using RISC-Zero's zkVM to be able to run it in a ZK fashion, but you can also do it without if you don't need ZK. So on top of that, you have the EVM, Solana VM. Essentially, you could have an unlimited amount of virtual machines embedded into this RISC-V architecture. So for now, we're featuring Ethereum, Solana, and we are featuring Fragment, which is our own virtual machine, and will be live if Cosm wasn't pretty soon. And depending on market demand, we will add more and more and more until we have all of them. So why would we do that? Is because basically we thought about this problem like this: be water, my friend. In a way, like if you want to have the best execution environment ever, you need three things. You need performance. That was the Monad founder was talking about performance a lot. The Layer N founder as well. So performance is really, really essential. And then you need flexibility and interop. Flexibility means for a developer, whatever language you have or whatever you have ever built or want to build in the future, you should be able to redeploy that, deploy that. Essentially, never sacrifice code. So if you have built something on Solana, you should be able to use that code without any changes somewhere else to vertically scale. And interop, in a perfect ideal world, all of these virtual machines can communicate together without any bridges or without any friction. So basically, performance, flexibility, and interop are the three most important things. Whoever achieves the best there will be the best execution environment. I don't think it's perfectly achievable. It's like a strive to perfection. And then, so this primitive we have built, we thought about it, okay, what can we do with that primitive, right? And because everyone was talking about layer 2s, we were like, fuck it, okay, let's do layer 2, right? Because everyone's doing that. And yeah, so we built in layer 2, which is a little bit different. So how it works is we have a multi-RPC. You can use your MetaMask, you can use your wallet connector, fountain, whatever you like, come through the network. And the RPC will communicate together with our multi-virtual machine execution layer. We'll choose the VM which you want to execute on. So imagine you want to use a Solana AMM, but you want to swap Ethereum tokens on it, right? You can do that with our system. So you would basically communicate through the RPC. The RPC would communicate with what we call the meta contract. The meta contract will send these instructions to the relative VM which is necessary for execution, and it would happen. I have better pictures for this. But just to summarize everything, so we have adapters which standardizes tokens. We are striving to get to parallelization. We're hoping Monad will lead the way so we can copy what they're doing. Because, I mean, that's fairly complicated stuff, and yeah, I mean, cool, good job. Cross VM calls, this is our kind of innovation. So obviously, because I said at the beginning, interop is really important. These VMs have to be able to communicate together. So bridges are, I think you said that, like, security is important, right? And bridges are the most attacked thing in crypto, right? Because it's like a honeypot. So you want to avoid bridges at all costs. So what we do is cross VM calls. You don't have to bridge between those VMs. They communicate together the same way smart contracts communicate together today on Ethereum. Yeah, and we have like language support for all the languages and unified storage. And here, this is really basically what explains how it's done. So imagine from above your transaction comes in, and now this basically host is kind of managing all that, the blockchain management system. And now you want to, let's say, do a cross VM call from the EVM here to the SVM and back to the EVM. So a data fragment, what we call a fragment, is basically not a transaction. It's part of a transaction called an action, goes into the meta contract. it realizes, okay, this is for the EVM, goes to an adapter who understands Solidity, translates it to Solidity, EVM knows, aha, you need that and that, translates it back to the adapter, it goes to the SVM, it gets executed, let's say it's a swap, and then it goes back to the adapter and back to the EVM. That's basically a very simple transaction. Now imagine this can be way more complex with way more VMs, but essentially it always works like that. Okay, so we have chosen to do a ZK rollup because of our friends of Risk Zero, but also because we think it's the future of how to prove things. For now, because we started with a full ZK rollup, realized that every transaction would be like $100, so that's not really economically viable, I think. So we said, okay, let's use the ZK fraud proof model, which we copied from Layer N, and it works really good. And yeah, so because this is like a primitive and not really, I would say, we don't want to be the custodians of that. Our product is the Layer 2. We're kind of inviting builders to use the primitive to build a Layer 1. That would be super cool to have like a MultiVM Layer 1, Validiums, and I think a bridge would be really, really cool. So you don't need all the state management, etc. So you could have a bridge with a MultiVM, where you have the cross-VM calls. Or like any other thing you can imagine you can build with that. So for now, on the roadmap, we will open early access in March. Some of the guys have already the private DevNet. We will make it available for all of developers in March pretty soon. Testnet is coming mainnet, and then we want to have like a stack where basically everyone can take the MultiVM, implement it in their system, and run it. That's basically it. And yeah, so because I'm here and there's a lot of smart people, we are like inviting everyone to collaborate. So what we need is high-load system developers, ZK engineers, RISC-V architects. Like, if you like RISC-V and low languages, like that's a really cool place to work. Infrastructure, DevRel, and if you have an anime avatar profile pic, that's perfect as well. That's it. That's my contact. That's me. Thank you so much.